Fossils are not rare. If you know what you're looking for and you go to the right sort of rocks, then they're pretty much everywhere. If you're looking for the perfect mantelpiece specimen, then you're likely to be disappointed. But if you just want to discover something new, something that nobody has ever seen before about this wonderful lost world of ours, i.e. the past, then you can do that remarkably easily. Whenever you're out on a walk, you might stumble across a new fossil site which tells you new things and opens up new puzzles. Hello everyone. There seem to be an awful lot more of you today. Whatever it was about Prototaxites, it appears that I've got an extra 1,000 subscribers in about 3 days. So welcome everyone, and thank you so much for signing up to hear more of this stuff. For those who are completely new, and that is rather a lot of you, what we do here is a mixture of things like covering news stories, trying to get to the nitty-gritty of what these new discoveries are actually showing us, discussing and debating problems and interesting arguments, debates in paleontology, and also doing our own research as well. So I'm a paleontologist, my wife Lucy is as well, she quite often pops up at some point, and we actually work where we live in mid Wales. We're basically independent researchers nowadays, so we're not paid to do this, but we've been through the entire academic system, we've done postdocs and so on, and now we live in our field area, or one of our main field areas, and carry on. So some of what we do is actually showing you the process that we go through to do paleontological research, what we're discovering, how we try to make sense of it, as well as doing the same thing by going through papers. So today we've actually got a little bit of the basic research side. So a few days ago we went off on a long walk because we're starting a local geopark as well, which is in case we didn't have anything else to do. And that involves doing sort of trial walks across the area to see what is available and what's interesting. And we actually discovered a new fossil site. This is, as I'll explain, a very unusual situation here because we've covered this area fairly well. And we weren't expecting to be collecting fossils, didn't have hammers with us or anything like that. So all we could do is finish our lunch very quickly and empty some bags and get a box full of rocks that we could weigh ourselves down with on the way home. And so what we're going to do here is have a look at these fossils and think about how they're preserved, what they tell us, how we can interpret them, and any surprising mysteries which mean that we're going to have to go back. So where we live is in the middle of Wales, as I say. So right over here, in a little corner called the Builth-Llandrindod Inlier. This is a classic area of UK and in fact world geology. A lot of the early studies were done around here on things like volcanic island systems, volcanic plumbing systems, paleontology. The first trilobites ever described in 1698 were from this area. And so it has a long, long history. I started working here as an undergraduate, which was quite a long time ago now, and I basically never left. Even as an undergrad, I was finding extraordinary sites, new faunas, soft-bodied preservation, and so I've never had any reason to leave. And since then, it just keeps getting better. So 2020 we discovered the Castle Bank biota, which we have some videos on and lots more as well, especially in the members section where it's for things that we can't put into the public domain yet because it's too secret. But the area that we live in, this inlier, an inlier is just an area of old rocks surrounded by younger ones. It's middle Ordovician in age, just going up into the late Ordovician, so about 455 to 465 million years ago, more or less. And the area records a volcanic island system in incredible detail. We've got the entire history of the island from before the volcanoes started erupting, when it was just a sort of silty shelf sea, through to the development of a Santorini-like caldera system about 10 kilometres across, various eruptions, vents all over the place, and eventually through to the collapse, the subsidence of this volcanic island, and it's being covered over by mud and silt and going back into quiet seas. And all the way through that sequence, we have fossils. Not just one or two, but really rich fossil assemblages. We have multiple conservat lagerstätten, these sites with exceptional soft tissue preservation, faunas that you don't get anywhere else. And so it just seems to be a never-ending source of fascination. It's also just a beautiful place to work. I mean, it's not high mountains, but these are 1,000-foot hills, and it's just lovely landscape. It's covered with Iron Age, Bronze Age, Stone Age relics, standing stones, ancient trackways, that sort of thing. And there's just something of interest wherever you look. So one of the dreams that we have here is to be able to reconstruct the ecological development of this volcanic island system in as much detail as we can, to give us a sort of template for how life was working, how the ecosystems were structured, how different parts of it all fit together. And so to do that, you need to describe as much as you possibly can of the paleontological sequence, which faunas were living in different places. So that is why any new site actually is of interest. Because there are fossils pretty much everywhere, but we don't have that many rocks exposed, and a lot of the ones that are igneous. They're volcanic ash deposits or igneous intrusions. But in the aftermath of the main volcanic eruptions, you also have a suite of sandstones, shales, chert, so silica-rich rock, all of these things being deposited from the erosion of the volcanic island. And so you end up with a wide range of rock types, which actually do have fossils in. So this day we were walking along on an ancient drover's track, probably several centuries old, going over the tops of the hills, past some Bronze Age monuments, as you do. And on the side of the track we stumbled across an area where it looked like it had been collapsing recently, so just a pile of little loose rocks on the side. And you can't walk past rocks without looking if there's any fossils in, especially if you happen to know from where you are in the sequence that it's the sort of interval which might have some of these things living in the shallow water. And within about 3 or 4 seconds we were seeing shells and other things. So, like I say, we didn't have any wrapping material with us. We only brought back something like 5 kilos worth of rocks, I guess, maybe 6 or 7, and lumps about this sort of size, which you can immediately see there are things on the surface. So let's start having a look at what we were finding and see what it tells us about this ancient lost world of a volcanic island in the middle of Wales. Right, the first one we're going to look at is this lump here, which is a piece of siltstone, very fine sand maybe, but quite fine sediment, thinly layered, it's a bit flaky, and the surfaces are covered in little holes and lines and so on. And we'll be looking at these down a microscope, which I can show you live, and it's quite a nice microscope. We've got a Leica, which is an S8 APO, and it also includes a cross-polarizing ring light, which is this bit down here, which allows us to change what it looks like quite considerably. Right, let's start off with this little beauty here, which is obviously a little shell. This is in fact just a few millimeters wide, but it's got some lovely detail in it. So you can see there that it's got these radial grooves, but there's also very fine concentric lines going around it as well. Let's just change the light angle and you can start to see those leaping out a little bit more clearly. And that makes it a thing called Glyptorthis furiosa in this area. There's only the one that looks like this, and it's quite a nice one. It's not something you find very often. It doesn't live in extremely shallow, turbulent water, and it doesn't live in deep water. It's got a very narrow range of water depth. We can't pin it down to meters because We don't know exactly. But it's not in the shallowest and it's not in the deeper muddy water either. It's actually quite a limited range of locations where you do see this little brachiopod. Now originally the shell would have been made of calcite, calcium carbonate, but it is completely gone. We're just seeing an external mould. It's quite three-dimensional, so in fact it looks like it's perfectly three-dimensional, so the rock has been cemented around it, and then the shell has dissolved, and you're not seeing any trace of the original structure left, which is fairly typical for things like sandstones and mudstone. But you start moving around and there's all sorts of little indeterminate little bits, holes and so on that you're not quite sure what to make of at first glance. Then you get much larger ones, so things like this. Hopefully some of you know immediately what this is, but for a lot of you it'll be pretty obscure. We've got a stack of effectively little thin polo mints, which are stacked on top of each other, and then inside of you they're crushed. So there's probably about 30 or 40 individual rings here. Again, it was made of calcite, so it's completely dissolved, and what we're seeing is the crushed mould. So this thing was, unlike the shell, the rock hasn't been crushed, but the fossil itself collapsed, at least, during the early stage of burial and deposition. And in fact, you can see there's longitudinal ridges where it seems to have crushed in segments. Okay, first things first, that is very distinctively, for those who know them, part of the column or the stem of a crinoid, a sea lily. They're actually quite common fossils in the Builth Inlier, in the shallow water, and we do get complete ones in a few locations. There's a place called the Llandegli Rocks, Lagostata, where we have fully articulated starfish, crinoids, sponges, various things from an extremely shallow water environment. And this here is a piece of the stem of one of these crinoids. Some of them had very thin, delicate columnals, just simple rings, and this is one of that type. It's something like a Cephanocrinus samgilmori, which is the most common one by far in shallow water. It's got these slight crenulations on the surface of these ossicles, so the articulating facets were reached, basically, that fits perfectly. And you have thicker and thinner ones giving this irregular outline. So it almost certainly is a piece of that one, just because it's so common around here. And you look around and you find more. There's one of the isolated rings. That shows you just how slender these things were. And yeah, it's almost certainly Cephanocrinus. And there are more bits and pieces here. It looks like these ossicles are actually broken up into separate segments in places. So there again we have almost as if it is broken into quarters. There are crinoids that have tetrameric ossicles. So rather than being a complete ring, they're actually 4 quarter rings forming each ossicle. And this is actually looking almost as if that might be the case. We'd have to look very carefully at this, try to make it out properly to see whether this is really what we're looking at. If so, it might well not be Cephanocrinus, because that one should have complete rings. Ooh, what we got here? A lumpy plate. Again, it's the external mould, so the plate itself would have had lumps on rather than little holes. And that could well be one of the calyx plates. Again, it fits with Cephanocrinus because it has little sort of lumps on some of the plates. Okay, you start looking around further and there's more and more little bits and pieces. More Glyptorthis. Not quite as nice, that one, but it's still there. Yeah. All sorts of fragments. Another of these plates, the calyx plates from probably Cephanocrinus. Quite nice. No complete calyx in this one, but you know, it's only a few pieces that we picked up in about 5 minutes looking. Okay, so let's have a look at the other side. inside is a little bit more weathered. So we've got lots of thick iron oxide film all over the surface, which doesn't help. But that's something a bit different. That you can see it's again a mould, but there are a series of tubes curving in to the centre from the right-hand side. And that is absolutely typical for the preservation of bryozoans, or moss animals. And they are also quite common in this area. They've never been described, because most of the taxonomic description of bryozoans depends on having the internal structure of the calcite skeleton, which is clearly gone. But it is a bit of a bryozoan. Ah, another Glyptorthis. Excellent. They're everywhere. It's actually quite surprising to get Glyptorthis so commonly. It's normally a fairly scarce thing. Ah, now that's something different. We have here a rod, which is not a mould. That is actually, oh yeah, with the cross polars you can see it's translucent. That is made of quartz. It's a long, thin rod made of quartz, which, and there's another one there as well, which is absolutely typical for a sponge spicule. So sponges were very common at this time as well, and there are some in particular that were really quite abundant that had long, thin spicules. And that, I think, is what's going on here. That's probably a thing called pyrotonema, which is just ubiquitous in the very shallow water environments of the Inlier. And what we've got there, that's another bit of bryozoan, is it? Let's have a look at the surface. Polarizer out to see shadows. Yeah, not a lot to see on that. Could be almost anything on a weathered surface. Unfortunately, that's often the way it goes. Lots of brachiopod shells. Okay, I think it's time we had a look at some of the other slabs, because this one is a siltstone, but we do have some coarser bits and some finer bits as well, some sort of chert layers. Oh, there we go, just before we go. That one is a bryozoan. That little array of bubbles all over the surface is the impression of the pores on the surface of the bryozoan. So it's a branched one, and it's just a small fragment, but there was a bryozoan here. Okay, but we've got better bryozoans than that. Have a look at this one here, and I happen to know on the back there is part of a really nice semi-complete, or a piece of a fairly complete bryozoan anyway. So zoom out as far as I can, because this is a big one. Where is it? There we go. That sort of bobbly texture is your bryozoan impressions of the tubes, and it's a branching colony. It's actually quite large, this. This is a good 2 to 3 centimetres or so. And the branches themselves are about 3 or 4 millimetres wide. So this was part of a large colony, I'll put it the other way up, which was sitting on the seafloor looking like a branching seaweed, but made of calcite. So there would have been, each of those little bobbles is the entrance to one of the tubes where the animals lived, so there were thousands of individuals in this colony, which together secreted this skeleton, which just kept growing upwards at the tips of the branches. And that is actually quite a nice example. We haven't got any of the fine detail of the internal structure that you would want, but such is life. This is something completely different. It's the only example we found in the few minutes, but that strange thing here with the sort of rounded edge on the right is a Librigina, a free cheek from a trilobite, specifically a calimonid trilobite, and there are quite a few species of these in the very shallow water around the area, but they're not often very well preserved at all. I think there's possibly a fragment of another part of it there, possibly the other Librigina, but it's really just that one bit. So when trilobites molt, they normally have a series of sutures that allow them to break up the skeleton. And the main things are the free cheeks. So these are bits on the side of the head with a suture along them, they can push out to the side, then crawl out through the front of the old exoskeleton and leave it behind. So they're very common bits to find isolated, because whenever they molted, this was what they left behind. So no way of knowing which species that was. I think it does remind me of one or two that we found at another site at one point, but probably can't get much further with that on its own. This is another nice brachiopod, very different one, I think called Parambonites. It's got a fairly distinctive sort of structure with sort of pits along these ridges. It's not well preserved at all. In a really nice one it's very distinct, but I'm seeing a trace of that structure here. And there's not much else which has this shape, size and that density of ridges either. So I'm pretty confident that is indeed Parambonites. And that is another one, like Glyptorthis, that we don't see very many of. So it tends to be in a similar sort of water depth. There's only one other site, I think, where we find them commonly, and that's about 5 miles away from this one. So it's interesting in terms of the ecology. And then there's this weird thing here. That really took me a bit of looking at when I spotted this one. It's a strange sort of what looks like a wrinkled sheet, but that is an impression. So again, there was something calcitic here that's dissolved out, and this is the impression of the underside of it. And you can see there also some of these ridges going through it that look very like the sponge spicules we were looking at before. Again, just impressions of them in this case, even they've dissolved this time. But it looks like you had spicules which are partly embedded within this structure that has dissolved out. So it's a slightly odd combination of structures we're looking at. And it's only when I could sort of peer in underneath that overhang there and break out a tiny little bit of it that I realised what's going on. Because this is another bryozoan. It's a sort of encrusting, mat-forming one, which has the upper surface you can't see because I can't quite manipulate it under the camera for you. But that is the actually a bryozoan that grew onto a couple of sponge spicules on the seafloor, which then got embedded into the skeleton. And then the entire skeleton's been dissolved out. And what you're seeing at is sort of growth lines on the base of the skeleton as this encrusting thing has grown out over the surface. So it's one of those things, when you first see it, you have no idea what that is, because it doesn't look anything like bryozoan. But all the holes that are the giveaway feature are on the other surface. So that's quite a fun one. Right, I think it's time we have a look at one of the best pieces. This one has a mixture of things on it. So we've got bits of brachiopods, we've got sponge spicules all over the surface, mostly impressions of them again. We've got bits of crinoid ossicles. That's a really lovely one there, isn't it? And here you can see the nodals and the internodals, so the very wide ones and the thin ones between them. That is actually absolutely typical Kevinocrinus. So that implies actually this one that was fragmenting in the way we saw before and didn't have such clear nodals and internodals is actually a different species. So we've got a piece of another one that I'm going to have to sit down and try to work out if we can find out what that one is. But this is the one that's really common in the shallow water of the area. Okay, we have other brachiopods around here as well. Look, more crinoid there. Where's the brachiopod? Ah, okay, that's part of a large one here. A few quite coarse ribs. Again, it's only a partial specimen, it's broken through it. I can see if I can get any more out of that, but that looks like Hesperorthis, which is an extremely common thing that dominates the extremely shallow water, so the mobile sand areas where it was just sort of beach deposits effectively. That's the only brachiopod that could live there. So normally they're attached to something solid, but these things seem to have been quite happy living just on this sort of sandy deposit and washing around with it, slightly oddly, unless they had a little muscular pedicle, a little muscular stalk that normally attaches it to things, unless that was actually going deep into the sediment to use as an anchor, but that of course has left no trace. more bits of crinoids all over the place. But here we start getting something very odd indeed. We've now gone into a slightly different layer. It's moved up a couple of millimeters into a very sort of slightly finer layer which doesn't have so much soft tissue in. And there are two of these bits with a black film. Now this is very odd. I'm using the cross polarizers here to really bring out the contrast, but the black looks like either carbon or iron oxides. It's actually quite difficult to tell which. But it's a very thin film. It's been crushed. You can see these radial fractures running along it, which is just longitudinal fractures where something has been broken as it was crushed. And there's transverse lines obviously running across it as well. There's not a lot of detail in here. Go into very high magnification and you lose all the detail. There's not much fine structure in here at all. But that's a peculiar thing. And the other one, just to the side of it, is in some ways even stranger, because it doesn't have that the transverse banding very clear at all. But the weirdest thing about all this is that what it looks like in its dimensions and its shape and the fact that it's a bit crushed is crinoid columns. But with a really strange preservation. So if that is crinoid, then what's happened there is we've lost the skeleton. It's all dissolved. And it appears to be instead a crushed organic carbon sort of residue of the outer surface, which was organic, a sort of skin around the ossicles. Could it be anything else? Maybe organic tubes of some sort, in which case it's not something I've ever seen in this area before. It's a very, very odd thing. And it's the sort of thing that you can't really identify what you're looking at from a single specimen. So we're going to have to go back to this site and see if we can find more of the same sort of preservation. See if it can pin it down to definitely crinoid by having something like a transitional type of preservation between this and the moulds that we're seeing just over here. I mean, it's not far away that we're getting these moulds. And moulds of fragments all over the place, and then suddenly go into a slightly different layer. You see I'm having to change the focus because we're going up about a millimeter. Perhaps slightly finer, chirtier sediment, and then we get nothing like it. So it's most likely, I think, that this is some sort of very strange preservation of a crinoid column, maybe including some of the organic soft tissue that's surrounding the skeleton. Yeah, not sure about that. We're going to have to go back and find some more. But that's really intriguing, because once you start understanding what the preservation is doing in these things, you realise when something just leaps out as being wrong. Okay, I've got one other thing I want to show you here, which is in a large block. Let's see if I can actually show you this. There we go. This is a block of effectively chert. This is extremely fine silica-rich rock, and going across the side here is this linear structure. And we look at this one under the microscope, and you can see that is a linear structure made of a dense mass of little rods. Spicules, in fact. This is a sponge, an articulated piece of sponge at least. You can see there's a few isolated spicules going off into the margin around it, but most of it is this densely packed mass of spicules. So, is this an actual sponge, or is it more a root tuft? Because there are quite a lot of sponges living in sort of soft sediments that have a dense array of spicules, like a rope of them, coming out from the bottom, which they use as an anchoring structure. And normally, if I saw something like this, I would be thinking that was exactly what this is. It's going through the rock. It's difficult to work out exactly which way up the rock is. Oh, actually, I think that is a surface there. So that, yes, there are other fossils on this upper surface. So in fact, this is going vertically, almost vertically through the rock, which means that is almost certainly an anchoring root tuft of a sponge that was living on the surface and has this dense rope of spicules anchoring it into the seafloor. Nice. Sadly, we don't have the body of it, so we have no idea, well, we don't have much idea about what sort of sponge it was. There's quite a lot of possibilities, but it probably had hexactins, which if you watch some of the other videos, you'll know that that doesn't mean it's a hexactinellid necessarily, but in this case, it's quite likely it was. There's quite a few shallow water, probably stem group hexactinellids that you get in Ordovician rocks, which we don't have anything quite like today. But most likely it's something of that nature. But complete sponge root tufts is not to be sneezed at. That's a nice thing to find. Even with this small number of specimens that we got so far, you put it all together and you start getting quite a nice bit of a picture. So if you compare with a reconstruction that we did many years ago for Llandegli rocks, this was one for the local museum displays, and you can see there it's got these pyritenema sponges with these massive brush-like arrangement of spicules, and there's crinoids there, including Kevnacrinus samdilmori and various brachiopods and so on. But everything there is on a significantly bigger scale, most of it anyway. So the brachiopods are mostly centimetre to 2 centimetre scale, whereas these ones we're seeing, the Glyptorthus, don't really exist at the Llandegli rock site. This is a much smaller scale ecosystem. These things were living mainly on much finer sediments, so they weren't attaching to pebbles because there were no pebbles in this environment. It was mostly fine silt, maybe very fine sand, but it's still fine material. There are a range of other brachiopods, the Parambonites again. I think in many years that I spent collecting at Llandegli rocks, there were 2 specimens, I think, of that turned up. And here we've got quite a lot in 5 minutes. You have also these bryozoans, quite a diversity of them. Now the largest ones are quite similar to what we see at Llandegli rocks, but the smaller ones, including there are fragments of fenestrate ones with sort of almost cage-like structures, much more delicate. And those ones we don't really see at Llandegli rocks. It tends to be something that can't cope with the really turbulent conditions there. So in terms of age, we're more or less at the same level in the sequence as the Llandegli rocks one. In distance, well, it's over there. If you can actually see the other outcrops from this site. So they're only, 2 miles away. But 2 miles in the context of a volcanic caldera, which would have had a large embayment, a sea in the centre, surrounded by a few partially exposed parts of island, and then the open sea beyond that. And you have there a recipe for localised populations which are entirely dependent on the precise conditions. So at Llandegli rocks you have things living very close to the shoreline in sort of pebbly, very coarse sand deposits. Here it's much finer. And this is presumably things that were washed off from the shoreline into, well, if I had to guess, it would be a complete stab in the dark, but maybe 20 or 30 metres water depth, something like that. Possibly slightly deeper, but not much, I'd guess. We know there are also, from work that we've done previously, similar types of deposits with, again, a slightly different fauna, which includes things like ostracods, tiny little bivalve crustacean carapaces, which are millimetre-sized, but they also tend to be in slightly deeper water than what we see here. So far, we've not seen any ostracods here. We also don't see many trilobites. We've got these 1 or possibly 2 Lidvigini from 1 specimen so far. And those are even those are unusual in the depth zone that we're looking at here. So they tend to become really dominant in the offshore, very quiet conditions, and in the very shallow water you get a different fauna. So this looks like one of the members of that shallow water fauna, which is just about managing to cope with these slightly more offshore conditions. In terms of the preservation, it's quite nice. We've got some articulated root tufts anyway. We've got some semi-articulated bits of crinoid. We've got parts of the column, not just isolated ossicles. These things have been buried after being washed around a little bit, but not very extensively. The brachiopods are mostly intact shells. Occasionally there's actually a couple of the two shells together still. The bryozoans include quite large chunks of colonies, so there's been some break-up, but not a huge amount. I mean, it's pretty nice. It's quite winnowed. They have been washed around, but we do have quite large chunks of at least the biomineralized things. So we're seeing things with a calcite skeleton, and we're seeing the spicules of sponges still preserved as quartz. But the calcite skeleton things are completely dissolved. This was an environment in which the water was quite warm and shallow, which is what you like to see for preservation of calcite, but it was also probably slightly acidic because of all the volcanic activity, and also very concentrated silica levels within the water, again because of all the volcanic ash in here. So you end up with chert. You get these silica-rich rocks which are precipitating quite rapidly in all the pore spaces and giving you quite hard rocks. That's not the sound that a bit of shale normally makes. So we've got here a biased community. It's preserving the biominerals skeletons and siliceous skeletons, but we're not seeing anything really here organic. Except possibly for that one weird thing. This slab with the quite nice bits of crinoid column on there, and then a couple of black bits in this other layer at the top, which appear to be crinoid column but preserved organically. And that really doesn't make much sense at all. And so what we want to do is go back and look for more of that sort of thing. So I think what we're going to do is take you back with us. When the sun comes out, which may be a while, I think the forecast is for rain for the next 2 weeks when it's not snowing. But when we get the chance, we now have a little a microphone that we can use out in the field. You might have noticed something clinging to my beard last time, but I was hoping it would improve the sound quality here, but it doesn't seem to have solved that problem. Anyway, we can use it outside. So hopefully we'll go back there when the chance arises and see what we can actually find in situ, show you how we work a new site, how we work out what there is there, and see where it goes. Because you never know what is going to turn up next. Anyway, thank you for that, and I will see you again at some point soon. Got a few possibilities on the cards at the moment. Got another one for the members coming up fairly soon as well. Yeah, I'm waiting for a paper from the authors, which might be a really interesting one to do as well, on myofauna in the Soom Shale. We shall see. Right, I'll leave it there for now, and thank you all very much for subscribing, and welcome aboard, and hope you've liked this one as well, even though it's very different from the previous video. There'll be bits and pieces of all sorts. Right, toodle pip for now.